One of America's favorite pastimes is sport fishing. Thousands of tournaments are held every year. And while these events provide an opportunity for anglers to showcase their skills and compete for prizes, they can also have negative impacts on the environment. Tournament mortality, or the number of fish that die after being caught and handled during a tournament, is shown to be close to 45%. Live wells are used to hold fish in the boat during the tournament day, but they are the biggest source of stress and trauma for the fish because of poor water quality, overcrowding, and high water temperatures. By addressing the poor live well conditions, we can reduce the negative effects of delayed mortality. So, how do we regulate live wells? Introducing the aLive&Well. aLive&Well will take the guesswork out of live well care by providing an automated and intelligent solution to a problem previously addressed with sensitive guesswork. Unlike traditional live wells, which operate continuously or on timers, aLive&Well monitors the dissolved oxygen and temperature levels constantly. It then relays data over an easy-to-read screen. It also controls a recirculating pump to maintain a healthy dissolved oxygen reading and will sound an alarm if the dissolved oxygen levels are approaching fatal or if the temperature levels are changing too rapidly. aLive&Well is retrofittable into any boat and can employ the recirculation pump or any other oxygenator to control and increase the dissolved oxygen in the water. So, how does aLive&Well work?
So let me take you through how this works. So right here we've got a DC power supply. It's a 13.8 volt, but it's good enough to simulate our 12 volt boat battery. So from here we've got a mock live well. This is the tank that would normally be inside of the boat already. The user's already going to have a pump of some kind, and they're going to have the tank for the water. Instead of a pump or along with a pump, they might have maybe an electrolysis-based oxygenator that we can also power with our box here. So we've got a temperature probe and a dissolved oxygen probe. That's protected with some vinyl tubing, some holes tied into it to allow water flow, some waterproofing here. But inside our box is where the magic happens. So let me guide you through the rat's nest. So we've got our sensor inputs coming in to a Whitebox. That's a shield for our Arduino. We've got those coming in, feeding into our sensors here. These are our EZOs. They send in over I²C a reading to the Arduino. We've got some other circuitry here to allow for motor control, alarm for critical conditions, calibration with a button on the inside tucked away from the user. And we've also got some plug-and-play features here with these banana jacks. But this is what allows our system to be retrofittable, and this could be condensed very, very, very small.
Up this morning, before the sun makes me some coffee, honey bun, jump in my pickup, gave her the gas, I'm going out to catch a 5-pound bass. Down by the lakeside, just off the ramp, all the people sleeping in their fishing camps, some out in the pup tents, some out on the grass, they all be dreaming about the 5-pound bass.
This project involved mechanical engineering in the fabrication of prototypes and electrical engineering when designing and making the circuits. In the future, we would love to incorporate an oxygen tank that would offer pure supplemental oxygen. Our product would then control a regulator on an oxygen tank. This would allow for the supersaturation of oxygen and an increase in pump lifespan, as well as a decrease in battery drain. Additionally, we want to further implement the circular buffer for the oxygen and temperature readings. If the readings are dropping significantly or rapidly, our system would calculate when to turn on the pumps or alarm systems before the conditions are critical. This way, our system would become proactive instead of reactive. So who's ready to help the environment and buy the aLive&Well, which will keep your bait alive and protect our ecosystems from delayed mortality?